Hi, Section 5, Metaprogramming. In this section, we're going to explore ways in which we can expand the Elixir programming language by means of metaprogramming. To do that, we'll first take a glance on how Elixir programs are represented internally, followed by ways in which we can manipulate and visualize that internal representation using quote and unquote. Finally, we'll take a look at macros, the de facto way to employ metaprogramming, and implement a sample macro. And with that, let's move on to the first video, quote and unquote. In this video, we'll explore the internal representation of Elixir programs by means of its abstract syntax tree, or AST. After that, we'll see how code is represented on the AST by means of quoting expressions. Finally, we'll see how we can inject values into quoted expressions using unquote. But first, a little question. What is metaprogramming and why do we need it? Metaprogramming is a feature in which we can represent computer programs as data. Elixir provides a few language features that help us leverage this, and we can use it to expand the language itself with new constructs or to change and evaluate code dynamically. All of these are pretty cool features, and there are many scenarios where they come in handy, but most applications you're going to be writing won't use these directly. You should be familiar with metaprogramming though, as it will give you more insight into how Elixir programs are represented and how they work. So let's consider this Elixir expression, which is a function call to a function named say2 that receives two arguments, an atom, David, and a string, hello. This function call can be represented in terms of Elixir data with a tuple containing 3 elements. This corresponds roughly to a node on the abstract syntax tree. All programs are represented by combinations of these nodes. The first element in the tuple is the name of the function being called. The second is a list that contains metadata associated with the node, which might include the scope of variables being evaluated. Finally, the last element is a list of subsequent nodes, the child nodes. In this case, since both arguments are literal values, they are represented directly, an atom and a string. All code is thus represented in this fashion, which we call the abstract syntax tree, or AST, due to its tree-like structure. The module definition on the left corresponds to the graphical representation of the AST on the right. Elixir provides a way to convert expressions into their abstract syntax tree structure representation, the quote macro. This macro takes a body of code and converts that code into the representation we've seen earlier on. Let's use quote to see the internal representation of some literals. Numbers evaluate to their own form. Strings also evaluate to their own form. Lists as well, with arbitrary size. And finally, tuples with 2 elements. If we try to do the same for a map, we'll see that the internal representation is quite different. It's actually a function call to the map constructor. Keyword lists, on the other hand, actually retain their internal representation, since they're composed of lists and tuples with 2 elements. We can try to replicate the example on the previous slides by using a function call. Let's call a hypothetical function hello with 2 arguments and see what the outcome is. And here is the representation. Function call hello, no metadata, and 2 elements, 1 and the variable called name. Let's try to bind some value into the variable called name and see if it affects the quote expression. It's still the same, so nothing changed. How can we inject the variable name into the quoted expression? There are times, however, when we want to have some value be expanded inside the quoted expression. Consider the expression 1 plus 2. Quoting that yields a function call to the plus function with the arguments being 1 and 2. We can use the unquote macro inside the body of a quote to force the evaluation of whatever is inside the body of unquote. In this case, if we unquote 1 plus 2, the quoted form is immediately evaluated to 3. Let's see how unquote affects the values of quoted expressions. We'll start by binding a string to a variable called name. If we simply try to quote the name variable, we'll see that the value does not get propagated inside the quoted expression as per the previous example. Now, if we instead unquote the variable name inside the quoted expression, we can see that the outcome is quite different. Unquote expands the value bound to the name variable inside the quoted expression. This means that we're now quoting a single string, and as we've seen from the previous example, quoting a string yields a string. So now let's pick up on the example we've seen on the previous slide and try to inject the value of name inside an argument to a function call. And as we can see on the outcome, the arguments to the function call hello are now David, the expanded form of the name variable, and 20, which is a literal value.